We are done with number system and sequence and series yesterday. And today we are starting with LCM and HCF. Okay. 2 to 3 questions have been asked as per the book. Okay. So the very first thing I wanted you guys to understand is about the factors. Okay. Let us say I write a number called 24. What are the numbers? What are the numbers divides 24? It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. When it comes 12, when it reaches half, just write the number. That's it. Okay. Right. Whenever it reaches half, just write the next number. After 12 up till 24, there will be no, for obvious reasons, if you assume that if 13 is a factor, then 13 into 2, it will spill out to 26, right? So it is not possible, right? So whenever you reach half, the next number is the number itself, right? So these numbers, so these basically are the numbers 1, 2, 3, 4, 6, 8, 12, 24. These are called your what? Factors. Okay. Why? Because these numbers, these particular numbers 1, 2, 3, 4, 6, 8, 12 and 24. These are the numbers which exactly divides this number called 24, right? Right. So 24, it's not equal to, is divisible by 1, 2, 3, 4, 6, 8, 12 and 24, right? All of you got it? What do we mean by factors? Yes or no? Just sit back and relax. Today we don't have much task to do over here, right? Just enjoy the show. Did you guys understand what do you mean by factors? What do you mean by factors? So if someone asks you whether 2 is the factor of 180, yes or no? Yes or no, guys? Yes or no?
Yes, sir.
Okay. Don't write in chat here. Come on, 2-3% and somebody Diwakar is writing in chat. Come on, do you have some fear, some issues or what? Come on in, speak up. Unless otherwise you speak up, leave this habit of writing in chat. Okay. You got to speak, you got to talk. Right? Yeah. So 2 is a factor. Is 2 is a factor of 180, Diwakar? Diwakar, is 2 a factor of 180? Yes or no? You have not rectified your technical issues up till now. That's the problem. Okay. So the answer to this question is yes. Right, Diwakar. That's correct. Now you tell me, out of these numbers, what are the numbers which are prime? And before that, is 1 a prime number or a composite number? 1 is a prime number or a composite number?
Sir,
1.
neither.
Yeah, absolutely. Neither prime nor composite, right? Okay. Diwakar, 1 is not the prime number here. I'm asking for prime number, not the odd numbers. So prime numbers are over here. What are prime numbers? 2 and 3, right? So these two are the prime numbers. So that means 2 and 3 are your what? Prime factors. Okay. 2 and 3 are your prime factors. Right, guys? Now let's just work around with 24 itself. What are these? What are these numbers with respect to this number that I have given? What are these? What are these? Multiples? Multiples, tables, you must have studied. 2, table of 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This is the 2 table of 2, right? This is the table of 2, and that means nothing but multiples of 2. Multiples of 2. Initially, it was only 2, and now it got multiplied to 4. Okay. And again, it got multiplied to 6. Right. Again, it got, increased this value, this number to 8. So what are these numbers? These numbers are your multiples, right? Now let me introduce another number. Tell me what number between these two are common? Which number is common? It's 144, right? 144, guys, right? So for these two, what is the common multiple? What is the common multiple? 144. Now what will be the next common multiple? It will be the multiple of this number itself. So one is 144. So next one is your 822. Okay. Into 3. Okay. Likewise. So these are all your common multiples, isn't it? 24 multiples are 24, 48, 96, 120, 144, 168. Right? And 36, the multiples are 36, 72, 108, 144. Right? Since 144 is the common, if you stretch it, you will eventually find that even 288 are common. Even 432 is common. Okay. Basically, it runs in the multiple of 144. So these are what your common multiples. What are the common multiples? 144, 288, 432. Which one of these three values is the least? Which one of these two values is the least? Which one is the least? 144?
Yes, sir.
That means least common multiplication. You understood what is common multiples, and now you have the least amongst the common multiples. Okay, so least common multiplication. What number is that? 144, right, guys? Okay, this is basically called your LCM, right? Let me erase the book. So we were working with two numbers, 24 and 36, right? All of you understood what is the least common multiplication? Now we'll talk about little bit about the methods of finding LCM. Okay. So there are two methods. Okay. One is your prime factorization method. Okay. Pardon my spelling. Yeah. Another one is called division method. Right, guys? So this is the division method. It is divisible by 2, both of them, 12, 18. Divisible by 2, 6, 9. Divisible by 3, 2, 3. Divisible by 2, 1. This is not divisible, just write it down. Okay. 3, 1, divisible by 3, 1. Now you do up till such a way that in the end you are left with only 1. Okay, only 1 and 1. Now just multiply these numbers. If you multiply these numbers, what you will be getting? Okay, we missed one number. Okay, 36. Sorry, guys. Look, the least common multiplication over here, 36, 72. Okay, is your 72 and not 144, right? Not 144. And the multiples of 72 will be the LCM. Right? You guys did not pay attention. I'm sure you guys are not the chaps who doesn't know LCM and HCF. Right? But anyways, happens. So what is this number? 72. This is one way of finding by division method. And another method is prime factorization method. Okay. It can be written as 6 into 4. That means 2 cube into 3. And 36. That means 12 into 3. That means 2 square into 3 square.
Yes, sir.
Right. Now write it in this way. Whichever is common. 2 square and 2 cube. What are common? 2 square is common. Just write it like that. Okay. Then write only 2. Then write 3. Okay. Now 2 square. What is common? 2 square is common. That's it. There's no more 2 over here. Then 3 common was there. Then 3 into 3. What are the commons? These two are common and these two are common. Just write it down. 2 square into 3. But the story doesn't end here. You have to write down the remaining ones as well. Now tell me, what is this value? What is this value, guys?
72.
72. Right. So 72 is your answer. And this is how we do it, by prime factorization method, right? Clear, guys? Are we good to go?
Yes, sir.
Common factors. Okay. Common factors. How should I tell you? Okay, let's say write it. Okay. 24 is divisible by 1. 2. Factors divide the number. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24, 36. We are not talking about common multiples. We are talking about common factors. Multiples are this way. 72. This is the number we missed. 36. Right. What are the number divides 36? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Half, full. Okay. Now what are the common? What are the common factors here? 1, 2, 3, 4, 6, and 12.
Yes, sir.
So these are your common factors. That's it. And which one is your highest common factor? Which one is the highest among all these?
12, sir.
12. Okay. So what is your highest common factor is also called as greatest common divisor. Okay. Right. So over here, this is called your greatest common divisor, also called as HCF, highest common factors. Right. And there are two ways of finding HCF. Division method, 24 and 36. Are you guys getting disturbed by the songs, which is getting played outside, or is it okay?
He can hear it, sir.
I mean, the song or me?
Song.
Oh, okay. So must be an enjoyable experience, I guess. Anyways, I'm in the hostel rooms in my university right now, so we can't actually help it now. Anyways, so first one is your division method. Okay. So how do you find division method? 24 divide 36. One time 24. What is the remainder? 12. 12 is the remainder. And now do this process again. This number, pull it over here in between. 2 times 24 gone. Okay. So which the least number, the number which essentially helped it to reach 0. The number which essentially helped the remainder to reach 0 will be your highest common factor or greatest common divisor. Both are same. Right? Now, factorization method. 24. How can we write it? 6 into 4, 8 into 3. 9 into 4, 2 cube, 3 cube. 2 square, 3 square. Sorry. What are common over here? What are the common? 2 square. In 2 cube, there is 2 square essentially. 2 square, 2 cube. 2 square is common.
3.
And over here, what is common? 3. That's it. That's it is your LCM. Right? Sorry.
HCF, sir.
Yeah. That's it is your HCF. Post this, if you write down all those which we did not consider, then what you will get? Then what will you get, guys? Just now I taught you how to find LCM using factorization method, right?
Yes, sir.
So these 1, 2, and 1, 3, these were the two numbers which we did not take into account, right?
Yes.
So if we include these two numbers, what will we get? LCM.
LCM. Yes, sir.
Right. Anybody who did not get it? Mateshwar and Divakar. Got it?
Yes, sir.
Cool, buddy. Thanks. So we are done with methods as well. Okay. Now the next concept is LCM and HCF of fractions. Okay. This is a very important stuff. Listen to it carefully because it has been asked previously. That's why it is important stuff. Okay. Let's say I give you some number. Okay. 4 by 8, 2 by 3. Okay. Let's say 5 by 8 and 7 by 10. Right. How to find LCM first? How to find the LCM of these four numbers? How to find the LCM of these four numbers? How to find the LCM of these four numbers or the fractions is that we find LCM. Okay, you need to find LCM. So write LCM of numerator, okay, divided by HCF of denominator. What is the HCF of denominator here? Highest common factor. That's going to be 1. I mean, if you do it, if you just take all these 4 numbers, what is that number? What is that biggest number? Biggest number that divides it all? That's 1, right? Not even 2, because 2 will divide all this, but not 3. Right, guys? And now find the LCM of these numbers. What is that? What is the LCM of these numbers, guys? Be quick here. Come on, I'll leave you fast. Otherwise, you'll be stuck with me. 2 times, 1 time. 5, 7. Okay, right? 7, 35, 70, 140. So what is the LCM? 140. So for these numbers, if I have to ask you, similarly, just applying this logic, HCF, what it is likely to be? To find the HCF of a fraction, we find the HCF of numerator divided by LCM of denominator, right? Now get me the numbers. Get me the number, guys. HCF of numerator is nothing but 1. By looking the number itself, you can say, right? Yes, guys. What is the LCM of 8, 3, 8, and 10? What is the LCM of these numbers? What's the LCM of these numbers, guys?
1.
Yes, that's correct. So LCM is over here, your 1 point. I'm sure, you guys, Mateshwaran, you know how to find the LCM? Mateshwaran?
Yeah.
You know how to find the LCM, no? Cool. If you do not know, ask me, I'll tell you.
Okay.
The last concept which we wanted to study today was about the relation between HCF and LCM, right? Okay. The relation, let's take this number 24 and 36 only. Okay. What was the LCM? HCF was 12. LCM was 72, right? Right, guys?
Sir.
I'm so sorry about all these disturbances, guys.
We don't hear anything, sir.
Yeah. Okay. So yeah, LCM and HCF. LCM is 72 and HCF is 12, right? The relation between LCM and HCF says is the product of the numbers. Okay. Hashtag means numbers. Is equal to LCM into HCF, right? This is the relation. This is also an important stuff. Remember it. Okay. Product of two numbers is equal to the LCM and HCF of those numbers. Obviously, LCM and HCF of these two numbers which we are talking about and not any other random numbers. Okay, so what do you mean by product of those two numbers? 24 into 36, which is equal to your LCM is your 72 and 12. Can you please, Mateshwaran, you please do this calculation, and Bari, Divakar, you will do 72 into 12 and tell me what number you guys are getting. Okay, is it 144? Sorry, not 144. What number you guys are getting? Mateshwaran, 860. Yes. How much you are getting? Mateshwaran, you need to do this one. How much did you say, Mateshwaran? 864, right? You also got 864, Mateshwaran? Yes or no, buddy? So we conclude that, what do we conclude? I mean, we are not concluding anything. They have already given us the formula and we're just checking, okay, does it work out or not? Yeah, it did work out. That means it's true, right? Shall we move, guys? With this, we are done with all the concepts almost. Just stick with me for 20-25 more minutes. I'll finish it off, okay? Shall we move, guys? Shall we move?
Yes.
Yeah. These are the few of the points, in the book that have been given. The only fund I wanted to tell you, whenever they ask you least, okay, whenever they ask you least, always you will find LCM, okay. Whenever they tell you maximum or max or highest or greatest or whatever nomenclature is that, okay, you will find HCF, okay. Ironically, okay, in a majority, not majority, in all the cases, LCM is always greater than HCF. Can it ever happen that for any number the LCM is, HCF is 1000 and LCM is 2? Can it happen like that? It can never happen. Okay. So whenever they ask you least means LCM. You need to find the LCM. And whenever they ask you max, highest, and all that sort of stuff, you will find HCF, right? Okay. The first one, it says the least number which divides x, y, z, leaving the remainder a, b, c respectively is given by LCM of x, y, z minus p, where p is equal to x minus a is equal to x minus b is equal to x minus c. Okay. Let's try to do it with the help of a question. Okay. It's this question basically. What is the least number? That means we are clear. Least number they have asked. Okay. That means we'll be working it out with LCM, which when divided by this leaves the remainder this respectively. Observe it carefully. 42 minus 25, 72 minus 55, 84 minus 67. How much is this number? Is it all the same? Is it all the same, guys? Is it all the same?
Yes, sir.
Okay. So what did we learn in the formula? Okay. Or for other matter, that it has to leave this much of this much of remainder. Okay. 25, 55, 67. Okay. That means if it is if the number which is being divided by 84, if it is 17 less than, when it is exactly getting divided, it will leave 67 as remainder, right? Now you tell me, what is the LCM? What is the LCM of 42, 72 and 84? Yes, guys, what's the LCM of these numbers? What is the LCM of these numbers? Let's try to find it out. Okay, let's 84. 72 into 2 is 144, 36. 216. Okay, 216, and 4 times is 8, and this one. Okay, and how much is the LCM, guys? 42, 72, 84, 2, 21, 36, 42, 3, 7, 12, 1, 14, 7, 1, 12, 7. Sorry, 2. Guys, let me know if I do any calculation error. Right? Did I do it correctly? 42, 84 into 6. 480 into 24. 405. Okay. 504 is your LCM, guys, right? So this number LCM minus these numbers, these are the same number we have got. Okay. 504 minus 17. How much is that? Okay. Had it been 20, it would have been 484, 487, right? Okay. Over here, there is an assignment for you. 487 is the answer, okay? The assignment is that you will divide 487 by 42 and 72 and 84, okay? And you will find the remainder. What is that remainder? Answer is there in front of you. That will be only 25, 55 and 67. But I want you to find out what is that remainder. Does it come something like this? You check it on that front, right? Fine, buddy. Can you do that? This is how the holistic learning happens, buddy. We push our mind to think from multiple perspectives, okay? Then the second one is the least number which when divided by x, y, z, leaving the same remainder r in each case. Okay, you know what? If you want to understand it, least number, it's saying least number. That means for sure we are going to find LCM, right? Okay. Now, if I ask you, find the least number which when divided by, let us say 10, 12 and 15 leaves 2 as the remainder. Okay, 2 as the remainder. Then what? Then the first step 1 is to find the LCM of the number itself, right? And then something like this, right? 1, 2, 1. By now, LCM must have got cleared for all of you, right? At least. What is the LCM, guys?
Yeah.
Sorry?
60.
60. Okay. In this number, just add whichever number was supposed to be the remainder. 60 plus 2, 62. Why has it happened? Why? We want 2 to remain at last. But we want rest of the numbers to get divided completely. So that number, we'll have to find a number which is divisible by all of these three numbers. And that to the least number. So we reach this number LCM. And when we added 2, this is that appendix part which essentially remains as the remainder. Right? Right, guys? Yes or no? I mean, when you do 10 divided by, 60 divided by 10, 62. 6 times 62 remain. 15, 62. 60, 2 remained. And what is that number? 12. 5 times 2 remained. Right? Do we have the same remainder in all the cases, guys? Yes or no? So we'll move forward. For integers x, y, z, if HCF is equal to 1 and if HCF of x and y is 1 and HCF of x and z is 1, then the HCF of x, y, z is always 1. Okay. So point number 1 is saying HCF of x and y. Let's just assume some numbers over here. Okay. If x is 9 and y is 10, what will be the HCF? 1. And HCF of x and z. Okay. Let's write it like this. Okay. Is it 1? So what is the HCF of all these three numbers? I mean the HCF of x, y, and z. What is that? Tell me, guys. Tell guys. The HCF is 1, right? HCF of 1. HCF is 1, right, guys? Are you guys feeling sleepy or what? HCF is 1, right? And also, if the HCF of this number was, let us say, supposed to be 5, okay, and let us say, suppose some number as 10, then this number over here, it was damn sure to be less than 5, right? For obvious reasons, that's a common sense. Right, guys? Are you guys getting it? Tell me. Are you guys getting it? Yes or no? If no, I'll tell you again. No problem. Guys, are you getting it?
Yes, sir. I'm getting.
Okay. So we are now at the second point, the greatest number that will divide x, y, z, leaving a, b, c respectively. Okay. So I'm asking the greatest number, okay, that will divide, let us say, 15, 20, and let us say 12. Okay. Leaving remainder 1, 2, and 3. How will you find that greatest number? Greatest number, they have said. Okay. What did I tell you? Whenever they ask you greatest number, what will you find? HCF. So one thing is clear, we have to find HCF. Okay. But how to find this HCF so that these numbers remain? So in that case, the first step is to subtract the number itself. 14, 18, 9. Okay. The greatest number that will leaving remainders A, B, C respectively is given by the HCF of x minus A into x minus B into x minus C. I mean, not into HCF of x minus A, x minus B, and x minus C, right? Okay. So x minus A is your 1, x minus 2 is 18, the greatest number that will divide. Basically, look, guys, there is no such number. That's why we are getting HCF as 1. Okay. The HCF of this stuff will be 1, right? So when this number is divided by 15, 12, or 20, right, it will completely divide it. Right, guys? Let me think of some different number here. One moment. The greatest number. So let's just take the numbers as 240, 160, and 360. Okay. These are your X, Y, Z. Okay. What is that greatest number? What is that greatest number which when dividing that divides these numbers X, Y, Z and leaves the remainder of 1, 2 and 3. Let us say A, B and C, right? Or otherwise, let's say it leaves the remainder of 10, 20 and 30. Okay. So what is that number which when divide these particular numbers to leave this as remainder? Okay. So the first step is to do it 230, 140 and 330. Now find the HCF of this. So how do you find the HCF of 3 number with division method? Look at it here carefully. This is the number, right? 1 time 140, 90, 140, 1 time 90, 50 gone, 90, 1 time 50, 40, 50, right? 40, 10. Okay, basically we are also finding this number all over again, which essentially completely divides this number. Okay, which essentially completely divides this number. Okay, let's try and check what happens when we leave the remainder as not this, but let us say we keep the remainder as 2, 3 and 6. Okay, let's check what happens. 238, 157 and 354. Am I understanding this point correctly? This point number 2, the greatest number that will divide X, Y, Z, leaving remainder A, B, C respectively, is given by HCF of X minus A, HCF of X minus A, X minus B, X minus A, Y minus B, and Z minus C, right? Am I getting it correctly, guys? Am I getting it correctly? Because whatever number we are choosing, all these numbers are getting completely, divided, right? It's getting completely divided. So what should we do? This is the second point, the greatest number that will divide X, Y, and Z, leaving remainder A, B, and C respectively. Okay, leaving remainder as A, B, and C respectively. Okay. So that will divide X, Y, Z. Okay. Let's pick up the number. Let's pick up the number something called 244. Okay. And it leaves the remainder of 4. Okay. And then let's pick the number 488. Okay. And it leaves the remainder of 8. Right. And let's pick another number and one moment, 968. And it again leaves the remainder 8. Okay. Right. So the first step is to find the difference. 240, 480, 960. Okay. What is the HCF of these numbers, guys? Highest common factor. What is the HCF of these? HCF of these number is how much? Guys, sleeping. I was thinking of some numbers. You are sleeping. Come on. What's the HCF, guys? Okay, tell the what's the HCF, then I'll finish it off. One of you tell. Slept by 11:30.
Sir, yeah.
Yeah. I mean, what is there to do, Abhikaran? See, you guys are
120, I think.
no. Think a bit more carefully. This number 240 itself. Think in terms 240, 480, 960.
Sir, 240.
Yes, 240 is your HCF. Right. And now check 240 when it divides 244 one time 240. What is the remainder? Okay. 240, 488, 480. What is the remainder? 240. What is the remainder, guys?
8, sir.
Clear? This is what they were telling. And the number that we were actually choosing, the problem with that number was that it was completely getting divisible by the HCF itself. Okay. So that those numbers did not work out. for some reason, right? I mean, for this particular reason. Yeah. Let's move on to the another concept. The greatest number. Greatest. They have asked you greatest. That means you have to find HCF. Okay. That will divide X, Y, Z, leaving the same remainder in each case is given by. Okay. Same remainder. Let us say I took a number, something called 242, 482, and 962. For obvious reasons, now you might have guessed it, why am I taking these numbers? Okay. We need to find some greatest number which, when it divides this number, in all the cases, remainder is same. So what it is saying, we need to find the HCF of what? 242 minus 482. This is in mod. Okay. 242 minus 962. And we have already worked with 242, 482. And with 962, now we'll work out with 242, 482. Right? Right, guys? What are the numbers?
Sir,
Yes. Yeah, 962, I mean. Right? What
no,
are
sir, we have to write 962 minus 482.
Oh, yeah. Yeah, you are right. 482 minus 962. Now you guys tell me, what is the difference? 242042. Okay. The second one is 962, 242, 027, right? And the third one is 962 minus 482. That means 08. What is the HCF of this? Other than Avikaran? What is the HCF of this number, guys? Divakar slept. Okay, fine. I promised you guys that if you tell me this, I won't wake you up. So the HCF of this is 24. See, look in terms of 24, 72 and 48. 24 into 2. 24, 2 times is 48 and 3 times is 72. Right? So the HCF is 240 itself, right?
Sir,
Right. And now you do the back end calculation. You divide 240 by 242. What is the remainder? 240 into 482. What is the remainder? 960. What is the remainder? Do we have the same remainder in all the cases? Yes or no?
sir,
Yes.
remainder are same, sir.
So these are the properties. Just trying to keep it in your mind. But if you understood the logic why it is happening, if you get to a point wherein you are able to pick up these numbers like this and think like what exactly the mechanism happening over there in the calculation, you will fall in love with this subject. Basically, that's what will happen. And yeah, it will fetch you good marks in mathematics examinations as well. That's the byproduct though. Okay. Anyways, let's move. Let's try to do a few of the questions. I'm sure you don't want me to do this, right? You don't want me to find the LCM of this, right?
Yes, sir.
Any one of you, do you want me to find the LCM of you? Divakar and Mateshwaran. Okay, these guys have slept. Again, LCM, we're not doing it. What is the least number which when divided by, what did I tell you? I've already
487.
Yeah, 487. Okay. Least number means LCM. We have to find the LCM. This is the clue that I'm giving you. And then you saw that the difference is 17, 17, and 17 in all of these cases. Right, guys? So what we did, we found the LCM of these numbers and we reduced 17 from there. Right? I guess I gave you a homework in association with it, with this question, basically. Let's move to the next question. Yeah, this one will do. Tell me which of these options you can eliminate without even picking up your pen. Okay, tell me what are out of all these 4 options, which are the numbers, which are the options not divisible by 9.
The C and D, both options are not possible.
Yeah.
So we can eliminate 2 options.
Yeah, we can simply eliminate two options. Like that. Slept, I guess. It's too late. Anyways. So find the least number which when divided by 5, 6, 7, and 8. So 2 of these options, your C and D, have already gone down to a toss. Only A and B remains. Find the least number, which when divided by 5, 6, 7, 8, 5, 6, 7, 8, leaves a remainder of 3, but when divided by 9, remainder is 0, right? So first we'll solve this part. What is that number? What is that least number which when divided by 5, 6, 7, 8 leaves a remainder of 3? Least they have said. So we'll work with LCM.
Option B, sir.
That's correct. What is the LCM of this number? Let's find out. That's it. I don't think we can do anything further. 20, 40, then 120, then 840. So LCM is your 840. Okay. But this is the LCM of 5, 6, 7, 8. If we divide this number by 5, 6, 7, 8, what will be the remainder? If we divide this particular 0, yes, 0. So if we want to find the remainder as 3, we'll have to add plus 3 over here. That means 843, right?
Yes, sir.
Okay. So, but over here 843. Now by dividing 9, it should leave no remainder. But if you add 8 plus 4 plus 3, this number is not divisible by 9, right? This number is not divisible by 9. And essentially, to leave a remainder of 3 means that if we find any multiple, let's say x plus 3, this expression will also, when divided by 5, 6, 7, and 8, will leave what? Remainder as 3. Yes or no, guys? Yes or no?
Yes, sir.
All the numbers in this format, because 840, the multiples of 840 will be completely divisible by 5, 6, 7, and 8. But when we add 3 to it, essentially adding 3 to it means that we are leaving it so that there is no remainder. I mean, there is 3 remainder, not no remainder. So if we put the value of x is equal to 2, why we are not putting x is equal to 1? Because we have already worked out with it. So that is 1680 plus 3, right? That means 1683. Is it divisible by 9? 819639. Yes, it is divisible by 9. Yes, it's divisible by 9, no? 1, 6, 8 and 3. Summation is 18, which is divisible by 9 by 2 times. That means, yes, we are concluding it is divisible by 9. Right, guys? Clear? Let's move. We don't want to do this question, right? You don't want me to do this one? Honestly, even this one? Yes, we were looking for this type of questions, previously asked question. Find the greatest number which will divide 400, 435, 541, leaving 9, 10, and 14 as the remainder. So whatever the remainder is required, first let's just get done with the remainder. This much of remainder needs to be there. This much of remainder needs to be there. This much of remainder needs to be there. Is the correct number? Right. So we are already accounted for the remainder that is supposed to be remaining at the end. Right? Yes or no? Now find the HCF of these numbers. How do you find the HCF of 3 numbers? There are 2 methods, but over here, for some reason, factorization method, it's not striking to my mind. Okay. So let's just work with the common division method, 425. First, now you will ask me, sir, division method, we can only work out with 2. No, we can work out with any number of numbers in order to find the HCF, right? So first we'll choose one particular pair, 391. How much is that? 34, right? Now you will pick up this number, 17 itself you will pick up. Okay. We'll pick up 17 itself and we'll write down something like this. That means the other number. Okay. 3 times 51, 1 times 17 is gone. So what is the answer? What is the basically HCF? And also the answer to this question, what is that, guys? 17 is your answer. Right. I hope you got it. I mean, those of you are awake. Okay. Yeah. We were here. Quick, guys. Quick. Finish it off. Take some numbers. Take some random numbers. For any integers a and b, let's take the integers as 2 and 3.
Sir, option B.
B you are saying?
Sir,
One moment. For any integers a and b with HCF a comma b is equal to 1, what is the HCF a plus b and a minus b? Okay. So let's just flip the script. Let's just assume a as 3 and b as 2. We don't want a minus b to be negative. That's why we have done that. Okay, right. HCF is 1. Now a plus b is how much? 5. And a minus b is how much? 1. HCF is how much? 1. But Abhikaran, you are saying it's always 2. We have also found out that it can be 1 as well. For what value? Give me the value.
units may be 1 or 2 either, sir.
What number did you work out with?
Sir, 7 and 3.
7 and 3.
Yeah.
Okay. So let's say 7 and 3. HCF is 1. It's clearly visible. Right. If you are not getting it, anybody, let's say, not getting it, then it's like that. Okay. This is your HCF. A plus B is 10. A minus B is 4. And the HCF of this is how much? What did we observe? It's either 1 or 2. Right. So that is why I've always been telling you, if you have to go by options, invariably a few questions like this will push you to work out with options only, right? Do not conclude by only one sample. Take couple of more samples. Okay, at least bare minimum 2, and at least 2, and maximum 3 to 4 you can work out with. That's enough, right? These many samples you should always work out with if you are going through the options, right, guys? Tell the answer, guys. HCF of 14, 21, 7.
Option A.
Yeah, that's correct. Okay, that means HCF of this number divided by LCM of this number, which is nothing but 7 divided by 45, right? Option A is the correct answer. I know it can get really dicey. It's 11:47 now. Let's finish it off. Quick, guys, quick. LCM of two numbers, let us say that number is A and B. Okay, the LCM of two numbers is 90 times the HCF. Okay, so if HCF is, let us say, X, so LCM is 90X, right? This is what they are saying. The LCM of two numbers is 90 times their HCF. The sum of LCM and HCF, okay, 91x is 1456, right? Sum of LCM and HCF is this much. One of the numbers, let's say A is equal to 160, then B is equal to what they have asked. Okay, right? We also know that LCM into HCF is equal to product of those two numbers. LCM into HCF, that means X into 90X, which is equal to 160 into B, right? That means 90X square is equal to 160B, right? No, right, guys? Are we doing some mistake somewhere? Just, guys, are we doing any mistake here? Let's try now find out over here. 91X is equal to 1456, right? The sum of LCM and HCF is 1456 they have given, right? So that means 91 into 1456, one time gone, 91, 456. Okay, so 6 times. That means X is equal to 16, right? So if X is equal to 16, your HCF is 16 and your LCM is this much, right? Right, guys? And what have we learned from here? Let's check this one. This is not required. LCM into HCF is equal to A into B, right? Your LCM is how much? 1440 into HCF is 16 is equal to A is a 160 into B, right? This 0, this one got cancelled, 16, 16 got cancelled. What is the value of B? What is the value of B? Abhikaran, you also slept. Come on, boys. I know it's going to be 12, in the midnight after 9 minutes, but that's okay. 144, right? Abhikaran?
Yes, sir.
Cool. Thank you so much. I won't disturb you anymore. But I'm sure solving this question won't hurt you. I won't do this one. I will do this one and finish it off.
Okay, sir.
Because last one is easy. What is the greatest number that divides this and leaves the remainder 17? What I have been telling you is that whenever we say greatest, that means HCF. Okay. Just the first what you should do is the account for the remainder. Okay. Count for the remainder. Okay. Right. So 13833. Right. 17013. Now let's find out the HCF of these numbers. Right. 13833 081. Right. Have I done it correctly? Avikaran, can you please check? Have I done it correctly? 720 12 3111 3180. 3 times? No. 2 times only. 2622. That means 4. 7 minus 2 is 5. And it is 8. I'll just write it down over here. 854 1113 1854. That is 9 10 5 10 2 7 7. Have I done something wrong somewhere? Guys, have I done it wrong somewhere? Yes. Why option B? Did I do
We have a format for this, right?
what?
If the remainder is same, we have to minus each of the number, right?
Sorry?
If the remainder of the numbers are same, we have to minus each other, right? We have to subtract.
Yes. So
Can we took that format which we can see?
oh, I mean the formula you are talking about, right?
Yeah, that format.
Yeah. So I'm just thinking, what is the greatest number that divides this and leaves remainder as 17? Okay. Right. So basically what we had a format for not same remainder. This is when they say same remainder, Abhikaran, look that one again. They won't specifically tell what remainder. Okay. Over here they have mentioned that remainder is 17 particularly, right? And that is why we are working it like this way. So this one, we just first account for the remainders by subtracting, right? So first we have kind of subtracted this number. What I believe we have done is that we have made some mistake in the finding HCF part. So I just wanted you to check, if we have done some mistake. Let me also check. 13833. Okay, one time 13833 0808 and 3180. This one is 26. Yeah, can you please check once? This one is 26. I mean 26. 3180 13833 4 times 0 031 111 3180. 3 times it won't go, only 2 times. 622 4 4 5. Yep, guys, over here we are supposed to 954. Okay, it's 954, guys. It's 954. So 159 954. How many times it goes? 954.
6 times.
6 times, no? Yeah, 15 into 6 900 or and 954. Okay, so what is the answer, guys? Option B. Okay. So sorry, guys, to disturb you at these hours. Thank you so much, Abhikaran, Mateshwaran, and one of your friends that you guys joined. Good night, sleep tight, and we'll meet again soon. Okay. very soon. Okay. Bye, guys. Good night. Thank you so much.